Welcome back. Today we're going to be looking at how we can actually use the idea of our IntNode object to build an IntNode array, looking at the very beginnings of how to do data structures using C++. As we look over here in our UML diagram for the class, we have on the left-hand side our IntNode object we've already talked about, and then we see the fact we're using the composed of relationship arrow, this lovely line with the filled in black diamond, and it says it's composed of 1 to n values. So our IntNode array is made up from at least 1 up to n values to make that. On the IntNode array, over here in our data member section, you can also see that we have the fact we have two data members that belong to our IntNode array. First, we have the fact that it has a private data member of size. Because we are making a non-hipster array, our data member is going to be private, and it has the idea that it's going to be of the right type as well. Additionally, we have inside our IntNode array, because we are building the data structure, we have to have a reference to actually talk to what is holding the information in that, and we're using that with the keyword right here, with a variable called front. It is of type IntNode pointer, and it's a reference we're going to use to talk to the front of the array so we can access all the different points along the data structure. Now, because we're keeping this really simple, even though it's going to be a non-hipster array, we're going to make it very simple and structured. We're not going to do all the stuff you could possibly do with an array on this. And just, again, because we're showing the idea of why it's important to actually use the idea of generics as we build our framework of data structures. This is simply to show what it takes to simply make a single data structure. And so I have right here a single constructor called IntNodeArray that takes a size as a parameter. And then we have three methods we're going to be working with as part of this. We also have our setAtIndex method, which takes an index and an int value as parameters, which is of type void because it changes something that has a void state. It affects the state. It doesn't need to return a value, so we'll just leave it as a void type. We have a method called getFromIndex. Again, we're using the idea of naming conventions. The method explicitly names what it's doing. So the getFromIndex, as we're getting it from which index, and it takes as a parameter an index of type int. And finally, we have a massively amazing tool, the getSize method, where instead of having a public data member that's final or constant that we see inside Java or we wish in C++, we have the idea of an actual method called getSize that returns the actual size of the array. So here we have our design of how we're going to do this. Let's go ahead and take a look at the data structure we're using to actually build this. So we can move over to our HPP file of the IntNode array. Here we have defined the class itself. Again, always start with the hashtag if and def. And because the fact we're using the IntNode object to build that data structure, we also do the hashtag include IntNode.hpp. So we can go to, when we actually compile this or build it, it links to the information inside IntNode.hpp, so it has access to all the information it needs when we're actually building the project. In our data member section, we have obviously our data member of IntNode pointer front, as well as the int size. That says that we're building right here. We have a data member we're going to keep track of to use the state information, keeping track of where the top of the array is, or the 0th index. We have in our public section, we have 3 methods and 1 constructor. And we, again, just like we saw inside the UML diagram for that, we have the fact that it looks a lot like that when we're actually doing the header file. It simply has the information of the name of the either method or constructor and its associated parameters that go along with it. Again, although C++ only requires the type in there, we are always going to explicitly define a good variable name for this so that when we look at the actual structure, when we're looking at what we're building, we know at this that we can see how we're building that and using it to actually design and write our code efficiently. And again, finally, always ending with the hashtag IntDef because we know that they know the class. Let's go ahead and take a look at the actual implementation for this. Inside the IntNodeArray CPP, we notice, of course, our first line right here is the hashtag include IntNodeArray.hpp. Notice that we are not hashtag including IntNode.hpp. That is already handled by being included inside this. We have it automatically included. Everything that's inside the HPP is included inside this as well. So we don't have to include that more than once, and it's actually a very important thing to remember when we're dealing with C++ programming, that we only include what we have to include. We also add a line of hashtag include assert.h. We are going to be using this to actually verify that our program will shut down if the incorrect information is supplied to it. So we've got that information there. We'll see that here in just a second. As you can see, we have our 4 methods that we actually have to go along with this. Again, noting with the idea of C++ class design that we have the name of the class, followed by the scope resolution operator, aka the double colons, followed by either the constructor's name or the method name that goes to that. So we have that same structure for all of our class as we go through this. So let's take a look at our constructor first. Again, notice that our constructor has a single parameter called size, and it, of course, belongs to the class IntNodeArray. We are then using the assert command. The assert command that we see right here links inside assert.h, and it forces the program to completely shut down if the test supplied after that does not pass. In the case we have right here, if size is not greater than 0, our program is going to shut down. We'll actually explicitly test this out as we look at how the code itself works in just a moment, because when we're building our IntNode array, we only want to have arrays that are actually plausible. In the case of this size, it must be at least 1 or greater. If we give it a size 0, there's no reason to actually make an IntNode array using that. And so we are explicitly defining the fact, using this assert statement, that you can't create an impossible array. So that's what that statement's for. And in fact, as we do our development throughout the data structures course, we're going to see this assert statement be the primary first line of almost every single method and constructor we make, making sure that we don't violate any of the rules or preconditions we have for designing our structure. So we'll see that quite often. Then, of course, because it's a constructor, its job is to initialize its data member. So the first thing we're going to do after that is we're going to say this selector size equals size. We're going to take the size parameter from that and assign it into the size data member. Amazing. We're following our basic rules of code. Now, we then move to our second data member, which is the front data member. Again, it's keeping track of our object structure that we're looking at this. And so since front is a node pointer, we're going to say use the new keyword because it's initializing it with a new chunk of memory, and it's of type IntNode. So we're initializing a brand new pointer to an IntNode object so we can actually use that and store information with this. And this is how we're going to keep track of our object throughout all of our structures as we go through this. Then, because we're actually building an array, we have to find a way of connecting all these different IntNodes together. And the way we're going to build those IntNodes together is we have an initialization of an IntNode, and we use its next pointer to grab onto another IntNode, connect to it, and it has a next pointer, and we can build all the way through, and then we can move the associated head pointer or front pointer along the structure, pointing to wherever the front of the current node itself is. So we use the magic power of the for loop to make that happen. So we have a for loop. We start with index is equal to 0. Index is less than size. Index goes up by 1 each time using the plus plus operator. As our first line of method, we have the idea of an IntNode pointer is created. Okay, and we're then using the new keyword because we're allocating new memory for it. This is actually, we're allocating new memory for this to happen as we do this. And I'm calling this current because it's only going to be used right now inside this lovely little block of code or scope of that for loop. And then I'm going to use this as the next line, current selector set node pointer passing it front. So I'm going to say that I have this brand new node right here. I'm going to say that its pointer is going to point to the already existing front pointer. So we hook it up and it's pointing to this. So that way we know that we have the only existing address we know of, in this case front, and we're going to set our new point node to point to it as its next one. And then I'm going to move the front pointer over here to this new one. So this is now the new front, and this one over here is just pointed to by this. So we're using a chained pointer to keep track of those information. And that's how we're going to build the sequential data structures. And in fact, many of our data structures with this is by simply moving a pointer along and making that connection and maintaining that connection throughout our code. And so that process will repeat as long as we have things to go on for that. And so we'll continue building our nodes point by point by point, always connecting the new node to it, keeping track, and then moving the associated head pointer as we move along. So that's how we're going to build our node array. And again, this is just a quick little simple one that can only hold ints. We'll see more complex ones as we move throughout the course. So the next thing we're going to go ahead and look at is the getFromIndex and setIndex methods. Now, again, just as we have right here, the class name IntNodeArray, then scope resolution, and then the name of the method. And again, I'm using the idea of having a explicitly defined method. It's getting from the index. We aren't limited to simply using a quick, simple method name, so let's use one that explains what's happening. And we use a parameter name that also explicitly defines what we're doing. So we collapse the constructor. We'll open up the method for getFromIndex. Again, notice we're starting off with that same assert command. This time, however, we're having a more complex assert command. We are making sure that the index parameter, the one that we're supplying with this when we're getting from the index, maintains two conditions. First, that the index itself is greater than or equal to 0. We have to make sure the index itself is valid. So first we have to make sure it's not negative, because any negative index doesn't make any sense to try and find something in the negative f spot of the thing. That makes no sense. It doesn't work for actually structure things in an array or list. The second condition we have to maintain is making sure the index itself is less than the size data member that belongs to the class. So even if I have only one thing, I can't supply it two. I have to make sure this is actually a valid condition. So I want to make sure that the index I supply is always within the realm. This is the same idea of an index out of bounds exception we'd be seen inside Java. We are explicitly defining the fact that we're making sure this is a correctly built and used structure. Now, I then make a new variable called int value. I'm using the same idea that we have because this is an int type method. I define a valid variable for this case. In this case, value is equal to 0. I define it as a variable that makes sense, 0. And then I have an IntNode pointer called current. Notice that there is no new operator right here. I'm not using new after the equal sign. because I'm simply pointing it to front. I'm going to look at the front of the array. However many things it needs to go back to, we'll take a look at that in just a minute. But I'm going to set my pointer current, set that to be front. I'm going to assign front into that pointer's value so I can keep track of this and use current to reference this. I don't want to change front. I only want to use current so I can iterate over my data structure. I am then going to use the magic power of the for loop yet again. I'm going to start my position off at 0, and then I'm going to set my position to less than index, that supplied value for the method. And every time I get through the method, I'll go position plus plus to iterate up one by one as I go through this. And what I'm going to do is, as I start off at 0, the first spot of my array, or sub-0 on the array, I'm going to go through and I'm going to say that current is going to be equal to current's node pointer. I'm going to move current down the array, all the way down until I get to the spot that I want to by saying current equals current get node pointer. So current's right here pointing to this one, and current node pointer is pointing to this one. So when I move it down, it's now pointing to this. And as I iterate through the loop, I'll iterate down to the appropriate value inside the IntNode array. As I go through that, that gets me to the right thing. And when my position variable is no longer less than index, and that fails that condition, I will have had my current is then going to be pointing to the object I'm actually looking for. At that point, I simply set my value equal to current getNodeData's value, so I can actually retrieve that value out of it, and I can return that. So again, using that int value, originally starting off at 0, reassigning that value to its correct and appropriate value out of the node itself, and returning that value for it. So we have the idea that in our getFromIndex, we're going to start at the beginning or at front, go down the array until we get to the right spot. Once we get to the right spot, we're going to grab the data that's inside that node object, store it inside this temporary variable value, and return that as part of the method. And so that's how the idea of our getFromIndex works. As we look down at our next method, the setAtIndex, again, just like before, part of the IntNodeArray class. However, this one takes 2 int parameters, and this is where it's very important to actually give variable names that make sense, because otherwise we won't know which parameter we actually want to use for this. So it's very important we name these variables effectively so we know what we're wanting to do. In this case, I have an index variable and a value variable. Again, because of the fact that we are building our own data structure from the ground up, we have our assert statement. The assert statement is going to be the exact same one we saw earlier in the getFromIndex method, making sure that the index supplied is less than or equal to 0, or excuse me, making sure the index supplied is greater than or equal to 0 so we can actually deal with a real value within our array, as well as the index is less than size, making sure we don't go outside of the bounds of the array. So we have that assert statement. If it is not met properly, we will go out of bounds and our program will crash, and we'll explain from there. And we'll see some examples of that as we get a little further on. We then again make a pointer reference. Again, we're calling this current, and we assign the value of front into it. So we're using the idea of making a pointer that we're going to look at front, use that to point to current, because we don't want to actually change what front is pointing to. We're just going to use where it's pointing to and make a brand new variable called current to point to that same spot. And then just like we did inside the getFromIndex method, we're going to use that same for loop structure. We're going to start off at 0, go to less than index, and spot, in this case, the variable, it also refers to the same spot of the array. We're going to go up by 1, and each time we go up, we're going to move our pointer to be the next pointer in the list, or array. And so we just keep on moving our pointer down the chain of pointer to pointer to pointer to pointer, moving it down until we reach the appropriate spot. Once spot is equal to index, we would not go and change this value because we're actually at that spot. We don't want to actually move any further. So then current at that point refers to the actual index we're looking at. And then because we've retrieved our index we're looking for, we're going to say current. We're going to call the method that exists on the IntNode array, on the IntNode object, IntNode right there. We're going to use the setNodeData, and we're going to change what's at that spot because it's a replacing variable, and we're going to change that to be value. And again, because this is a void, it's only affecting the state, it's only affecting right here, we're setting the variable right there for that. So our getters and setters inside this IntNode array work very similarly. We have the idea that we create a pointer. We start off at front. We iterate from spot to spot to spot, or index to position to position to position, up until we reach the index that's specified as a parameter. Once we're at that spot appropriately, we then either change the variable using setAtIndex or retrieve the value stored there using the getFromIndex. And so that's the idea that we're actually going to be building for this. Finally, because we are not making a hipster structure, we have an actual getter for the data member that belongs to this in the case of size. And so we have an int method called getSize that belongs to the IntNodeArray object. And it's going to use the amazing single line of code to return this selector size to tell us how big this data member, to tell us how big this array is. We can actually ask the array what its size is, unlike everything else inside C++. We know how big we are. So we're having a properly designed structure right here. So again, we have a quick review. We have those three methods, that belong to the IntNodeArray class, the getFromIndex, setAtIndex, and getSize methods. We also have our IntNodeArray constructor that specifies the size, that initializes our size to be the correct data number we can also use as our getSize method, instead of having to pass a second parameter around. So there's our class. Let's go ahead and take a look at this in action. I have built my standard idea of our controller object over here in our MVC relationship. And we're going to take a look at our controller HPP really quick. As you can see right here in my class data structure controller, I have my start method that I use to always start my programs, and then my testIntArray private method. So again, it's a private method, and we can see right here that it's only going to be valuable to our data structure controller object. As we look at the actual CPP file, notice that we have our HPP right here to actually access our data structure controller object.hpp. So we have the reference to the class design right here. We have access to our IO stream, so we can use the C in, C out and access the streams themselves with our using namespace std. But also notice that we have the hashtag include or pound include, and then ../model/intnodearray.hpp. Again, notice I'm only pound including the HPP file right here for this class. It's very important that we only use the HPP 99% of the time as we do this, because we only need the header information most of the time for what we're doing. So inside this, as you can see by looking at the actual structure of the class, there is no differentiation between the private method of testIntArray and the public method of start when we look at the actual header or any of the code inside this, because the public and private information is only seen inside that header file. It knows what's public and private inside itself, because that HPP right here is what people access to actually look inside and see what they have access to when they're trying to use that object. So again, looking at our start method right here, my start method, I simply just say I'm switching to the IntNodeArray testing, so I can actually go look at that. I call my private method of testIntArray, and then I simply get a nice little cout statement to say finish testing. So my start method, really pretty basic, don't need to worry about that at all. So we'll go ahead and close that out. I'm not going to look at that any further. We'll go ahead and down here take a look at our data structure controller method called testIntArray, and we can see how we're going to test out what we're working with. So I'm using the simple cout statement saying testing the array, and as you can see right here on line 30, I say an IntNodeArray object called temp is going to be equal to IntNodeArray passing it the parameter of 0. Now remember, when we actually set up our IntNodeArray object, we said that the size itself has to be greater than 0, and this is where we're going to see what happens when we use an assert statement in our code. And then after I do that, I'm going to use the ability to test through and iterate over my data structure, using the for loop going of index to 0, index is less than 3, going up by 1, and using the idea of getting from the index what's at that spot, and just using a simple cout statement to say what's inside there. I'm then going to test how to use input using another for loop. We're using testing the IntNodeArray input. I have another for loop, again going over from 0 to 3, going up by 1 each time. In this case, I'm going to use temp.setAtIndex, passing it index and index as both parameters. So setting it at 0, 0, setting it at 1, 1, ... We're going to use that to simply just go ahead and make that happen. And finally, we're going to verify that that input actually worked by reading the output file from that same thing. And so we should see that the getFromIndex is at spot and then index. So the numbers that are returned should also match right there. So we should see that the index itself matches as we go down through that. So let's go ahead and take a look at how this runs and see what happens when we supply incorrect information to our assert statements. So we're going to go ahead and Command R. Our build succeeds, always a great sign. And switching to the IntNodeArray testing, and notice testing the array, that line from that happens, and then assertion failed. This line right here, size greater than 0, we failed that test. It also takes us explicitly to it right here inside our debug screen, saying that we have a signal sigart because it was an abrupt end to the program. And so we know that we failed right here. Our size is not greater than 0. We did not pass that test, and so it stops the program immediately. So this is why the assert statements are so helpful as we're doing our data structures. We can see explicitly when something incorrect happens right there because our program shuts down. I know it's not fun when our programs crash and burn, but right here by force crashing this because we've actually made a mistake as a either user or implementer of this program, we know what that mistake is because we've explained right here that this test has to pass in order to go through the code. So we go ahead and we'll use that to move on. So I'm going to go ahead and go back to my code, go back to the controller, and instead of having a IntNodeArray of size 0, we'll replace that with 3 because that's what I'm using all the way through here. I'm going to go ahead and close my debug screen again and rebuild this. My build succeeds again, and We're going to go ahead and take a look at this. Switching to IntNodeArray testing the array. -999 is at spot 0. Again, as we saw inside my IntNode.cpp, we explicitly defined that node data of an uninitialized member of that to be -999. So we know that even when we create this automatically, we have something in there. It's not just a 0 of just some random int. We know what this is because we defined it in advance to be that value that's explicitly easy to find. So we know that that worked properly. Moving back to the code really fast. So we have right there, so I have spot 0, is it spot 0, is it spot 1, is it spot 2? So I have my lovely section right here where I'm actually going through getting -999 from each of those 3 spots. That means my IntNodeArray constructor worked properly. Fantastic. Let's go ahead and test the input on that. We're going to go ahead and index 0, index is less than 3, index plus plus, and we use the setAtIndex method where we're going to set that value. We verify that's working by looking at input, and so this time instead of looking at spot 3 on that, we're using the temp.getSize method. We're using the verification that the size parameter itself properly works, in this case right here. And so 0 is at spot 0, 1 is at spot 1, 2 is at spot 2. Finished testing, our program ended with exit code 0. Fantastic. This worked properly. So we can see right here how we can actually effectively write this code to use the idea of an IntNode object to test how to store simple data, in the case of an int, inside a data structure. Now, as you can see, because we're using this IntNode array, like we talked about last time, if we did not make another thing like a string node, a car node, a monkey node, a Pokemon node, we'd have to also explicitly make a Pokemon node array, a car node array, and any other data structure type that we want to make. We have to make the associated data structure all along with it. And that will get very, very inefficient. And so what this is going to lead to is the fact we need to make a better way of storing data. Rather than simply having a typed thing and a typed thing array every single time, we have to use what's called a generic or a template to make it so it can hold any kind of thing, making it so we can actually make things much more effective. Just as a quick review, going through our overall structure of the data structure we've built, we have our IntNode array inside the UML. In this, we have the fact that we have 2 data members that belong to the IntNode array, a size and front. Front is an IntNode pointer, refers to the actual front of the array or the 0th index of that. We have just a quick little set of methods of getIndex, setAtIndex, getFromIndex, and getSize, as well as a single constructor that takes a size parameter to build the actual data structure. Those are this IntNode array is composed of, using the composed of operation here, of IntNode objects. Each IntNode has 2 data members that belong to it as well, a int that stores the actual data itself, as well as a pointer called node pointer that we use to refer to the next node in the array. We have the getters and setters that belong to the actual node object, as well as the basic constructors to initialize those values. So that's how our IntNode and IntNode array is actually structured, put together. We have a quick little header file review right here of HPP. The IntNode HPP looks just like the UML diagram, where it simply explicitly defines what the constructor and methods are, as well as in the private section details the data members that belong with it. We have our implementation file, again, of IntNode CPP, where we simply assign a default value of -9,999 for all of our node data, so we can explicitly know that we did not initialize the value properly when we're looking at that. And then our getters and setters for the node pointer and node data look just like they would inside a regular Java program inside C++, where it simply says that the parameter that's passed in as a variable goes and is assigned to the data member, or if it's a getter, that the data member is simply returned back out. Really easy to go. Looking at the header file for the node array itself, again, we have 2 data members that belong to it inside its private section of front and size. Notice we don't have a getter of front because we don't need to worry about this in the simple version, but we do have our method accessor of getSize, so we can actually get the size of that, having a non-hipster object, because we don't want size to be a public data member. No. We also have a single constructor that takes the size parameter, and then 2 methods, setAtIndex and getFromIndex, that affect the state or return the value from that. And looking at implementation as we go through that, again, the constructor, we simply verify that the size itself is valid. We then assign the data member, create a reference to front as a new pointer object, and then iterate over the size, building new pointers each time, so we can then connect them together to make the actual array of int nodes, building that up. On the getFromIndex, we have the same basic approach where we verify the index is a valid value that's within the realm of 0 up to, but not including size, because we start counting at 0. We then default the value of 0, iterate over the structure, moving the pointer down one element at a time throughout that using a for loop, simply starting at 0 up to index. And then once we reach the appropriate value or index inside the array we retrieve the data from that, pour it in the value variable, and return that right there. On the setter, we again use that same approach, asserting that the index itself is a valid value within the realm of the size. We make another reference to the front header pointer, go start that off at current, iterate over the structure until we get to the appropriate node, and once we get to the appropriate node, we set the node data to be value, and then with a really easy method to getSize, we have that happen. Looking over the actual testing of that using it inside another program, we look at our controller object right here, and inside our controller object we have the test_int_array method, and we then declare an instance of it. We iterate over it, getting the values, and iterate over it to assign values, and then retrieve the values yet again. So we have a quick little version of how this works. Again, this is just a quick, simple version of using a data structure. It can only hold of type int, and so if we wanted to make anything more complex, we either have to use the idea of generics or make billions of copies of lots of things and make billions of data structures. Definitely a much more efficient way is to make a more templated or generic type that we can use using the magic of the angle brackets, our first gang sign, that we can actually create and use information to make data structures. Thanks, and have a great day.